Welcome, everybody, to the American Space Museum. I'm Mark Marquette, and we're so glad you're with us to stay curious today with Caleb Keaveney beside me, who is an astronaut scholar, the first one we've had on from the Astronaut Scholarship Foundation. Welcome, Caleb, Caleb Keaveney.
Glad to be here.
And glad that you are here.
Anything.
And
That's
Caroline Shumacher's over here.
I
Caroline.
know.
Caroline's our friend of the museum. She, the last 5 or so years, has been the CEO and president of the Astronaut Scholarship Foundation, founded by the original Mercury astronauts, to provide scholarships for wonderful students like Caleb here. And so we're going to learn about what his forte is in science. You're going to Yale. He's working on his undergraduate degree, and it has something to do with this background here that's swallowing us up. What's that all about? Okay, it is Monday, and you know I like doing backyard astronomy on Monday, so this is going to fit just great in our theme. But Caleb, tell us first. I'm going to jump over here to first to Caroline. Tell us a little bit about the Scholarship Foundation and your big event of your Hall of Fame induction.
We have a big event coming up. So I think most of this audience is probably familiar with this, but just in case you're not, the Astronaut Scholarship Foundation, as Mark said, was founded over 40 years ago. We're hanging on to the 40th anniversary celebration by the original astronauts. There were 6 surviving in 1984 and some of their friends to establish a way to keep America at the leading edge of technology and innovation. And we feel our vehicle to do that is by identifying and awarding the very best and brightest in STEM across this country. So we partner with 51 universities.
51.
51. We'll have 70.
And is the Ohio University in there?
The Ohio State University.
I mean, the Ohio State.
There, yes.
Not OU. And
Not OU.
Athens,
They're too busy partying on Halloween. So,
yeah.
but our Buckeyes are, yes. And the scholars, they receive up to $15,000 in funding, plus professional development programs like coming to our Innovators Symposium and Gala in August, where we have a professional expo. We have professional mentors that volunteer their time to pair up with the scholars annually. And then we stay really engaged with our scholars. So Caleb is actually a 2023 astronaut scholar from North Carolina State University. And so he's actually doing his graduate. I'll just give you props that you're actually in your graduate program, your PhD program at Yale.
Okay, good. Yeah.
But that just shows that our scholars are with us for a lifetime. They're part of our network and our family. They come back and volunteer at events, participate on panels. Tomorrow, Caleb is presenting at Kennedy Space Center on his work. So we're really proud that they're out there, really kind of sharing the love of space exploration, STEM, and then certainly sharing their story about ASF. But next up, you asked about our next big event.
Yes.
And that's the U.S. Astronaut Hall of Fame induction gala. That will be on May 31st. We have a whole weekend of activities. We're going to be inducting Bernard Harris and Peggy Whitson this year. So really exciting to bring them both into the Hall of Fame. And it's sure to be another memorable weekend, starting off with Cocktail Challenge on Thursday, speakers and panels on Friday. So there are cosmic level tickets and gala tickets left if anyone's interested in hanging out for the weekend.
ASF.org or com?
Astronautscholarship.org.
Okay.
Yeah. And you can find us on all the Facebook, Instagram.
And we're going to be promoting that, of course. We always feature the astronauts. We love what the Scholarship Foundation does, and Caroline is becoming a good partner of ours. And as you all know, at our Shuttlefest, Stay Curious Watchers, we had Shuttlefest this weekend. So that's why my bags are under my eyes. Caroline, she flies all over the place. It's just, Caroline, I've heard from many people what a great job you've done.
Very nice.
And those include some wonderful people like the great legend Bob Seek and others on there. So,
well, that's very flattering, but it's very easy when you have amazing scholars.
It is.
Like
well, it's the kind of same kudos I get for Shuttlefest and other things I do. It takes a team of people to do it. And we appreciate your participation at Shuttle Fest there. Hope, who was there? Kirsten?
Kirsten came. She had our vendor booth. She said it was
Yeah.
awesome. She loved seeing everyone. Had so
Yeah.
much fun engaging, and
And
we'll be there again next year for
well,
sure.
we're taking it to different levels, and we'll have a couple shows about it, show you some of the love we got from the participants, as well as, we've been touting 4 awesome astronauts, Eileen Collins and John Grunsfeld, Joe Tanner, the 2 Hubble astronauts, and then of course Don Thomas was just if I was an astronaut, I'd probably be Don Thomas, because he's just a regular guy that got pretty lucky in there. So they were all fabulous. Those of you that weren't there, hope you can. We're going to get the save the date out hopefully here in the next couple of weeks, even, because we know a lot of love for that. So that's enough of the love fest between me and Caroline here and our respective agencies. But this is what is so interesting, I have found, living on the Space Coast, is we have access to such wonderful people that built the rocket ships. Caleb, they flew. The astronauts are awesome, but they were about the space workers. Okay,
Yeah.
Marty Winkle worked on the lunar module that is going to the Apollo 13's happening 15 years ago in real time. And the lunar module that he helped build, and you see our little pictures up around there, it's truly an amazing vehicle. It's never been duplicated, and we celebrate all these space workers, and some of them have put payloads in space that you're probably working with data. So let's find out about Caleb. You see what I got lined up here on your expertise, but first, Caleb Keaveney, where did you grow up, and you're into planetary sciences?
Yep.
So where'd you grow up, and did you look through telescopes and go, wow, how'd that all happen?
Yeah, so I grew up in Durham, North Carolina. It's kind of I grew up really in the heart of the Research Triangle, so pretty much equidistant between.
They call it the Research Triangle now?
Yeah,
It used to be Tobacco Road.
Oh,
That's true.
yeah. So I kind of grew up where the Research Triangle and Tobacco Road kind of intersect. So
Okay.
I grew up like halfway between UNC Chapel Hill and Duke, and then a little bit farther from NC State. So I kind of grew up surrounded by these very high achieving academic institutions.
Absolutely.
And there were a lot of opportunities for things like volunteering at museums or just going to museums. We took
How about
field
high
trips.
school? Did you do science fairs and things like that?
Oh yeah. So the big thing I did in high school was build rockets.
Build rockets?
Yeah.
With the Estes rocket things, or your own
So
concoctions?
we were competing in a couple of different challenges. So one was like smaller model rockets they were a little bit bigger than the Estes kits.
Uh-huh.
And then we built what we called high powered. Of course, they're not actually like high powered rockets, but they'd be like 7 or 8 feet tall.
That's
And
pretty big. Yeah.
they'd use like solid rocket motors, and they'd go up to about a mile in altitude. And so my twin brother and I were big into these rocketry competitions, and that was really what got us into the like space program career path. We did those rocketry competitions, and then we got to go down to NASA Huntsville, launch them.
Cool.
And then that got us into college. And then when we got to college, we kept on doing our
Well,
space
twin
stuff.
brother here. What's his name?
His name's Aiden.
Aiden?
Yep.
Okay. Hi, Aiden. I'm sure you're going to watch this. Marty's a twin brother
All right.
also in there. We run into quite a few twins. In fact, Caroline, I'll drop a dime on her. She said she was talking to Charlie Duke today. He's got a twin brother, doesn't he?
Ooh.
No, not.
Maybe.
Charlie Duke has a twin brother? Yes, he does. And his twin brother was a dentist, I think, in the Charlotte area. Steve Jokums knows that, Marty. If he's watching, someone will correct us on that. But Ed White was a twin.
Oh, really?
Yes, when he passed away in the fire, I've heard people say that they saw his twin brother walk down the aisle at the funeral, and they about fainted. They thought they go like, what in the world? And yeah, so anyway, did you? What kind of animals did you put in those rockets?
Yeah. So we
A
didn't.
mice or two, or cockroaches? Or...
We didn't put any animals in them, but one of the teams we competed against put in ants.
An
Uh,
ant.
and like they put in like a colony of ants, I think, to see if they would survive. But because it was like a high school competition, there was a lot of safety stuff, so we had to have the rockets totally packed, ready to go the night before. And I think the ants didn't survive the night before the launch, so they kind of missed out on their
Well,
science
animals
experiment.
are
But
huge in the shuttle era. We celebrate the shuttle era and all. What'd your brother Aiden do? Is he science too, or?
so he's in law school now, but his degrees are in physics and math.
Wow.
So he's kind of in a lot of different areas all at once.
So what kind of family did you grow up in? You sound like you have solid parents that
Oh yeah.
pretty smart.
Yeah, no, great parents. My mom's a physical therapist in a retirement community, and my dad's a
So-
social worker.
Oh, well, God
Um,
bless them. Good for
yeah.
them. That's not always easy days at the office there. So,
Yeah.
well, good for them. And are there any other siblings in the family?
Yeah, I got one. Well, two older brothers. My twin's older, which I should say,
You
or
call your twin your
yeah,
older brother?
he'd be mad at me if I didn't say he was older.
Yeah, we know that.
But yeah, my other older brother is
Who-
he works in he works in tech sales, and he's in more the finance world than I am. So we're kind of all
That's
spread out
good.
a little
He
bit.
can
Yeah.
help you save your money as a scientist and all
Yeah.
that stuff in there. Marty, you interject on that UCAC family microphone.
Yes, Charlie does have a twin brother named William, known as Billy.
And
Really
Charlie's going to be 90 years old this October, and that's hope his brother is too. Charlie, the youngest moonwalker. Let that sink in with y'all there, okay? And, coming up on 90. By the way, I look pretty good there with this.
I know you're
Mercury
rocking the
thing
brand.
there.
I like this.
Yeah, I got my vest on, but I'm rocking these are my heroes, Caleb, without a doubt. Growing up, the Mercury 7 astronauts were my heroes. I had a little brother. He was on the top bunk of the bunk beds, and I pretend them springs up there were the dials and stuff that John Glenn was messing around with in my fantasy world there. So I love and it's just it's really one of the most beautiful monuments or tributes, whatever, in a museum I've seen, how they did the acrylic reliefs of the Hall of Fame astronauts in there. Well, let's get to your career here a little bit then. You're studying, tell us what that's about, and two planets that you're working on very deeply.
Yeah, so when I was in college, I was a freshman in college when the COVID pandemic started. And so I had always had this interest in planetary science. And then when I was in my freshman year and I took a meteorology class, and I was like, okay, this is really cool. And I was like, how can I do planetary science through meteorology? Because there wasn't like a planetary science major at my school. So when the pandemic started, I changed my major into meteorology, and I emailed a professor, and I said, hey, I have this interest in meteorology and planetary science. Do you think that'd be cool to do a project? And he at the time anyway didn't know anything about planetary science. He was entirely an extreme weather meteorologist. But we started this project on the Great Red Spot on Jupiter, and that's how I ended up getting into this weather and climate on other planets.
And it is so important, a field that, being an old stargazer, these fields that weren't even thought about even in the 80s, like astrochemistry, astrobiology, and astroweather. I'm glad to hear this. We're going to put space probes out there investigating and drop them on parachutes inside. You got to know that a lot. So here is a picture of Jupiter, and of course that is the Great Red Spot there. Did you have telescopes in your backyard, that sort of thing?
I had a telescope, a very small one growing up, and then I got a slightly less small one, I think probably late in high school. It must have been like sophomore year of high school, because there was a lunar eclipse my junior year of high school that I remember looking at through my telescope. But I didn't specifically look at any planets until I got to college. And then I was a freshman in college, or a sophomore in college, and I was looking at Jupiter, and I was like, oh, I can see I can see the Galilean moons, and I snapped a picture through my telescope, and now I use that in all my talks.
Well, this is by my
But-
friend Johnny
Awesome.
Horn from Greensboro, North Carolina area up there. He worked for, can't remember the newspaper he worked for up there, but Johnny's a good stargazer friend of mine. And to see Jupiter through a telescope is to really see a planet in motion. Tell us what we're actually looking here. And of course, this is a big, well, just I wanted to advance there that we do talk a lot about the planets. They have no choice if they watch Starry Curious, because I'm doing Stargazer Mark on both Mondays. You see, last February I talked about Juno, a spacecraft now orbiting Jupiter. And what can you, it's just, you can be in awe looking at these planets. And the physical characteristics of Jupiter allow us to watch these cloud bands move in motion. Tell us what I want you to tell us what we're looking at.
Right. So Jupiter is such an interesting planet because it's really this laboratory for what people who do what I do call geophysical fluid dynamics, which is just how
Geophysical fluid dynamics.
right.
Okay.
It's how fluids move around on planets. And in particular, what a planet is just a rotating sphere. And so we have this rotating sphere and this just deep layer of gas that is rotating with the planet. And because of things like the sun heating different parts of the planet more than others, and the planet rotating, you get these really interesting dynamic weather phenomena. And so when we look at Jupiter, everything we see is a reflection of that. So at the equator, we have this bright band of clouds that moves eastward relative to the rest of the planet, and it moves very quickly eastward. So that's what that central white band is. And then as we move poleward, we have these alternating bands of colors, which are associated with different directions of fluid motion. And so and all that is expressed in colors on Jupiter, which is unique. Saturn has a little bit of coloration too, but Jupiter in particular has these really interesting colors with it too. And we also get these long-lived storms like the Great Red Spot because there's no surface. So there's no
surface on, you study the gas planets, Jupiter, Saturn, Uranus, and Neptune.
Right.
So they don't have a surface on them. We're looking at weather.
Yeah, so they have essentially like the gas just gets more dense the deeper you go, but there's no solid interface at any point. And so
There's some conjecture of weird things like metallic hydrogen or something like that at the core, which we can't even duplicate on Earth, correct?
right, yeah. So this is where things get really interesting, is where do you define the bottom of the atmosphere and how does it actually work there?
Let me go to a picture here, Caleb. Yes, folks. No, folks, it's not a Van Gogh painting or some crazy abstract artist or something. I mean, it is a gorgeous.
It's amazing.
What is happening here is meteorology, correct?
Oh yeah, yeah. So this picture actually I used I interned on Juno when I was in college, and this picture I did science with. So you can see, well, I guess
This very picture
right
that I
here.
pulled out of the hat.
Yeah.
Awesome.
So
Where
right
at?
up here,
Uh-huh.
this band of white clouds, there's really small, if you go online and zoom in on it, you can see these really tiny features that look like popcorn. We call those pop-up clouds. They're really small. They're like small cumulus clouds, basically. And so what I was doing when I was interning at JPL was I was looking at those little clouds and seeing where they cast shadows.
Ooh.
And where they cast shadows on the clouds below, you can measure the length of the shadows and use the geometry of where the sun is to figure out how high up above the clouds below those tiny clouds are, which can tell you all kinds of things about how those clouds are forming, what the structure of that area of the atmosphere is. So that's what I did science with this image.
What's your extreme meteorologist professor think about that when you come up with this stuff? He's like probably pretty impressed.
Well, so this was when I was not working with him over the summer, and then I came back and told him about it. He's like, okay, that's pretty cool. But
Yeah, he said because he wish he thought of that. Okay. I
Yeah.
want to point out that is a great. Marty's got a question there too. What is so hard to comprehend is the layering, the three-dimensional layering. Because Caleb, tell us a little bit about some of these, like is the brown area, is that above or below the white areas? And look at this little white mini storm up there, a mini white spot. And so
Yeah.
forth. But there's a lot of different. It's like clouds on Earth. Right.
Yep.
The cumulus are low ones. The cirrus are real high.
Yeah, so when you look at Jupiter, the brightest colors are generally speaking the highest in altitude. So
Okay.
the white band at the equator, these white clouds that you see in this image, those are overlaying the brown orangish colors below. And we know that because if we look in different wavelengths of light, these brown bands are brighter in the infrared, which is where heat is emitted by the planet. And so the fact that they're brighter means that there is more heat that is reaching where our sensors are detecting, which means basically we're sensing deeper in the atmosphere. So most of the red areas are deeper in the atmosphere, with the exception actually of the Great Red Spot. The Great Red Spot is at higher altitude, but for the most part, the brownish red areas are beneath the white areas.
Marty, we've got a question.
Yes, Michael Bruno was asking, can you model the Great Red Spot? Can you predict how long it will last?
That's a great question. So that's I published a paper last year about
There
this.
it is,
So,
of course, and this is our backdrop.
yeah, so this is the work that I was doing that won me the astronaut scholarship. So my mentor Gary and I at NC State, we had this idea to simulate the Great Red Spot because he studies extreme weather and he does numerical modeling of weather systems, and I had this interest in Jupiter, and so we kind of merged our interests at the Great Red Spot. And the idea was to run some numerical simulations because there's only so many observations we can do. So if we really want to study it in detail, we can do some modeling, develop this model of it, and then mess with it to see if we can make the storm evolve. And so it's been shrinking for 150, 200 years.
That's the key. This is one of the
yeah.
first things seen through a telescope, not by Galileo, but a couple other better telescopes later.
Yeah, so it's been shrinking, and that's been largely unexplained. It's
How big is it? What are we talking
Right,
about
so-
size here?
so Earth would be about it would be
Maybe
so
that one there.
so
No,
on the
big.
Great Red Spot. So in this image, this is 1.3 Earths across is the Great Red Spot in this image. So
Okay.
Earth would fit inside the Great Red Spot somewhat comfortably, but not twice.
Okay. Used to be bigger twice.
Used to be bigger.
What's
Yeah.
interesting is you can. It's like a little something plowing through the water. It's spinning, and the white vortex around it is leaving the trail behind it. Correct. It's actually moving through.
Yeah.
But
So,
what did they say? It's
yeah.
a hurricane or tornado that's constantly been fueled by we don't know what, right?
Yeah, so it's somewhat similar to a hurricane, but it's actually kind of the opposite. So hurricanes are what we call tropical cyclones,
Mm-hmm.
which means tropical because they form near the equator, and then cyclones meaning they rotate in the same direction as the planet rotates. The Great Red Spot's an anticyclone, which means it rotates the opposite direction of a hurricane. But it's similar in that it is a very large rotating weather system. And so in this image, it's rotating counterclockwise and moving to the west. And it's been doing that for 200 years, for as long as we've observed it. But it's been shrinking, and then as it shrunk, its motion has accelerated as well. So it's
gotten faster.
yeah, so
Ah.
it's been plowing through the atmosphere even faster as it's gotten smaller.
What's all this stuff down here? This is like I said, it looks like somebody's crazy painting or something. It's
Right.
just so odd or exotic and beautiful in many ways. You got
Yes.
these little white things. Are these storms? Is this?
Yeah, so this is turbulence in the atmosphere. So this is when you have just essentially chaotic motion where there isn't really a general. There is a structure going on, but within that, it's like when you pour your creamer in coffee. you get these swirls.
Oh, perfect
it's
analogy.
it's exactly the same fluid
Really?
dynamics. So
Why do we need to know this? Why do we need to know? What do we need to know about Jupiter and all this?
so for one thing, it's very interesting to be able to understand these worlds, because we only really, living on Earth, we're just looking at one example of a an object of which there are thousands of. Like, there are thousands of planets. There's 8 in our solar system, but there's all these exoplanets. And so just if we just looked at Earth, we would really only understand one specific case, and of course a very rare case, because we're the only planet that has produced intelligent life that we know of. And so by understanding all these other worlds, we can understand in general how solar systems form, how planets work. And the Great Red Spot is a really interesting example, because we can make analogies with features that we see in Earth's atmosphere, but it behaves differently because it's in Jupiter's. So the paper that I published last year made this analogy between the Great Red Spot and what we call blocking highs, or heat domes, which, for people who live in the northern part of the United States and in Europe, it's very common that heat waves in the summer will be associated with a high pressure system that just kind of sits over one area.
Mm-hmm.
And it's relatively long lived for various reasons. It requires some kind of mechanism to fuel heat into it or to otherwise sustain it. And when that happens, you can get these really extreme heat events. And they happen on Earth, but of course there's stuff we can learn about them by looking at them on other planets too, where the parameters are a little bit different.
Excellent answer. Great way to tie that together, Earth and Jupiter. Here's maybe the closest image we use as the backdrop here of Jupiter. What's also interesting I wanted to say is, through a telescope, Jupiter is really big. Right?
Oh,
well,
yeah.
let's go. I'll talk about that here. But man, this is one of the most detailed, the heart of this
Yeah.
structure that's been seen. In the 70s, it was really red in the telescope when I was a teenager, and just it was just red as can be. I got a few Kodachrome pictures of it from my backyard in Hancock County, Ohio.
All right.
But there's another beautiful picture of it. Tell us how big Jupiter is.
Yeah, so Jupiter, it's, if you just lined up Earth across this image, you could do that about 20 times. Or no, sorry, about 11 times.
It's
I
8.
had to do the math there.
Yeah,
So
right. We're 8,000 miles. It's 88,000 miles across.
something like that, yeah.
But the volume is everything in the solar system can fit inside of Jupiter.
Oh yeah, yeah.
Even Saturn, the rings, all the moons, all the 70 moons can fit inside of it.
Yeah,
That's hard to comprehend. That's how big this is.
right. Yeah, and it's 2.5 times the mass too. So, and
big influence in our solar system
yeah.
with comets, of course, crashing into it. We finally saw a few of those with the Hubble telescope, Shumacher Levy 9. I remember that.
Those are really cool images to look up. The Shumacher Levy impacts. They left like basically bruises on Jupiter.
Oh yeah, it was phenomenal.
Which then there was weather associated with that.
Too bad they hit on the back side, and then when it come around, we saw. But the other thing, though it's so big, it's got a fast rotation. Its day is how long?
Its day is 10 hours long.
10 hours long.
It's, Earth could fit inside it like 300 times, but it rotates 2.5 times faster, which is, it has some really interesting effects. So this image, if you overlaid a circle on this way, I'm not the TV kind of meteorologist. So, so if you put a circle on Jupiter, you could see it bowing outwards around the equator.
It's flat at the poles.
It's very oblong. And then because it rotates so quickly, that constrains how large weather features can be too.
And because it rotates so quickly, here's a sketch I made years ago in my backyard with the red spot. That's actually one of the moons. The 4 Galileo moons project their shadows on there. And what's fascinating is, in a matter of 2 hours, the red spot will go from over my head to over to Caleb's head. All right. Or one of the other directions there. But this is not scientific. It's just more
Well,
For me, it's I am looking at a planet in motion.
yeah, I'll push back on it being not scientific a little bit because these kinds of drawings are actually very important for people like me who are interested in how these planets evolve over long time scales. Because for a long time, we couldn't get really detailed, we couldn't get images
Mm-hmm.
of Jupiter. So the only way to study it really was to make drawings. And so for the first like 100, 200 years of observations of Jupiter, we just have drawings. And so
Yeah.
we can track things like the Great Red Spot based on artistic renderings. So there are papers from 5 or 6 years ago that go back and document how long the Great Red Spot is across and just
Mhm.
track its size evolution. And before like 1950, the best data we have are from drawings.
Absolutely.
So even drawings like this that aren't, as you say, the most like precise or scientific are can be very useful. So
No, thank you. I go with the yeah. It's just for me. It's like I recorded. I was there. Sort of like taking a snapshot of the Grand Canyon or something,
Mm.
you know. But I've done this obsessively over my stargazing career because I just find it's keeps the brain waves flowing. And,
yeah,
and I love looking at them.
I've always wanted to do something like this.
Caroline,
Yeah.
Huh.
yeah,
Yes.
you following this?
Yes. Oh, they're over my head. All the scholars are over my
Uh,
head. No, I think it's
I
fascinating.
mean,
Yeah.
this you know something very practical that you're doing too. You've got a question for Caleb or something that we might need to know about him?
Well, I'm just super proud. I'm really excited that he can share all this. That was actually a really fun fact because I didn't know
Mhm.
that drawings were used. Of course, that makes sense.
Yeah.
You know that's how it was documented. So I think that's I appreciate that point of view. But
Yeah. And the day being only 10 hours is why that's possible. 'Cause
Oh,
you
and
can
it's
see
so
one
really it
full-
moves so fast and
Yeah.
the moves move
Right.
fast, and if you watch it, because now summertime it's going to get dark late, but in the wintertime when it gets dark at like 6 o'clock, you go out and start looking at it, and you go out 10 o'clock before you go to bed, and it's like a whole new view. And
how did you feel when you got published? Like,
Oh,
was
wow.
that a
Yeah.
pretty big feeling of accomplishment?
Yeah, I mean, that was I worked really hard for that because that was a project that me and Gary conceived of really like on Zoom during the pandemic when I was 19, and this was just going to be a fun, you know, he didn't have any hope for it. I had like some hope that it would be something cool, but never that it would actually become like publishable and contribute to our actual like broad understanding of Jupiter. So
That's awesome.
it was very cool. And then seeing it in like, you know, it got a couple of articles written about it, and I was like, wow, this is more than I ever thought it could be. So,
hope you're enjoying this conversation with Kevin Keaveney here
Caleb.
with Caroline
Caleb.
Shumacher, and did I say it wrong?
It's Caleb. You've
Well,
got
that's what I
you've got a
said.
shuttle fest fog. So
Yeah, I
it's
have
Caleb. It's
Caleb
fine.
Keaveney there.
Yeah.
Thank you, Marty. Straighten out. 2023 might be your scholarship. We put
Is it 22 or 23?
it was 22 through 23.
Oh, so
I
you're
was-
22.
it was-
We would
yeah.
call you a 22. So
Well, you all get the gist of what the Astronaut Scholarship Foundation is all about by talking to this young gentleman. You went to your undergraduate work at?
North Carolina State.
Okay, I almost said the other one, so I'm glad I didn't. And graduate work at Yale,
Mhm.
and kind of a different culture there to
Yep.
each place, huh? From you know, a Yaley to what was the Carolinas? Your
Tar
That's
Heels?
The Wolfpack.
A wolf
the
pack.
Wolfpack.
Yeah.
Tar Heels. the other one.
That's the other one. That's the
Yeah.
other one.
Is that kind of a culture shock for you? I mean, a good one. In a good way. I'm not criticizing anything, but
Yeah, it's definitely a bit of a culture shock. I think, you know, I grew up going to public schools my whole life, from elementary school all the way through, graduated from
yeah, a lot of
public
Yale
university.
students go to private schools. You're kind of insinuating in a way, or
Well, so the graduate students are a little bit different because I don't know much about the undergrads. I don't want to generalize the undergrad population, but the
Mhm.
grad students I found to be surprisingly more from like public schools than you might think. But you're still surrounded by, you know, these huge Gothic architecture, and everything looks like it was either once a church or now a museum, and it's there's a lot of which isn't to say that NC State wasn't this like really cool. It was just different. Like it was very modern, a lot of tech all over the place compared to Yale, which is a lot of really old books and
Probably a lot of tradition. And
yes, a lot of
history.
tradition.
Mhm.
There's signs everywhere that say like for God, for man, and for Yale, which is not that's not like you
Wow,
don't say
yeah.
like for God, for man, and for NC State. You know,
Uh-huh.
it's a little bit different. But there's benefits to both for sure. Like I really appreciated going to public schools my whole life. I feel like I got to know a lot more people from a lot of different backgrounds by going to public school. And then now at
Yeah.
Yale, I benefit a lot from the resources at a place like Yale.
That's awesome.
So
Well, I'm enjoying this. Hope you all are. Marty, we got any comments or questions there?
Well, there are quite a few comments about Shuttlefest. Everybody.
Yeah, we'll
enjoyed
get
it,
to
but-
Shuttle Fest
right,
tomorrow.
Yeah,
and
that's
the
why I'm not
next-
bringing that up.
Yeah, I'm enjoying this a lot, not just because of the subject, but because this is what the Astronaut Scholarship's been doing for how many? 40 years.
40 years will be
How-
41 in August.
And
or
how
July.
many scholarships in general?
So
in-
855 scholarships
In
and
40
over 10
years,
and,
wow.
and over $10 million distributed.
What I had the opportunity, back in January, there's another Juno shot of the red spot. Back in January at the Spacecom,
Mhm.
I really enjoyed the
The panel that
panel
we had.
that you
That was
had
really good. Yeah.
of those young. Was there 4 of them up there?
We
I
had
think?
4. We did
Yeah.
emerging technologies.
Of what they had accomplished in their careers 4
You
or 5
know,
years
I mean,
later.
it was Julian Marino, Grace Robertson, Colin Burnett, and
Yeah,
Wilson Turner.
Yeah, that was one of my favorite panels because it really, inspires people with what they're doing. But they were all, Fergie was there.
He was our
Ferguson,
moderator. Yeah.
moderator, and
We'll have another panel at ISTC.
oh, will you? Okay,
Mhm. Yeah,
all
we're
right.
gonna have a
Well,
panel there too.
International Space Development
Yeah.
Council that I am on a panel about with Jay Honeycutt, and
Oh, cool.
we're going to do the Sunday afternoon slot about the past, the legacy type of stuff on there.
That's
so
awesome.
look,
good.
I'll be check. You're going to be on it, or some other
No,
people?
I have others on that one. No, you're doing. Are you doing when you're coming? Presenting tomorrow at Kennedy Space Center.
Yep.
What do I have you doing anything after this?
I don't,
After that one, do I have
I
you
don't think
assigned
so.
anything?
I mean, feel free.
I know.
Would love to.
I get it a little mixed up. I'm like, who's doing what right now? But
Well, let's go. A couple more things on
so you got to
Jupiter.
ask him what he's doing now too.
Yes, just an unbelievable world. It's also like you mentioned. Is that not coffee in your or creamer in your coffee there?
It does kind
Yeah.
of look like coffee.
Okay, and also oil on water. And
Yeah,
in
or
the
like when
hippie
you drop
days, we
paint.
used to have the projector with the odd things on the screen while the band was playing in the back there. But so look it out. Juno is. Tell us why Juno is so unique.
Juno is
Spacecraft of
Right,
NASA.
yeah, so
Launched here from the Space Center.
yeah. So it launched in I believe 2011, and then arrived at Jupiter in 2016, I think.
Mm-hmm.
And I was in high school, and I saw the pictures like this on the news, and that's when I really got into like, okay, maybe I could do planetary science.
Ah.
And so then in college I got to work on Juno, and it's a really interesting satellite because it has this polar elliptical orbit. So it goes over the poles, and then it gets in really close on its closest approach, and then shoots way back far out.
Like 6,000 miles from the surface, and then
Yeah.
goes out to like 1,000,000 miles.
Something like that,
But
yeah.
it's going super duper fast.
Really fast. So it's like so fast it can take like 40 images as it's going over
Wow.
this huge planet. And so it gets these really close up images about now. I think it's once every 3 or 4 weeks. It gets a really close approach, and we get these beautiful images.
One other thing I want to
So-
show, we're going to skip over Jupiter and Uranus there just a second. I mean, Neptune, Uranus. There's lightning in them there clouds, and this is an artist's conception, but are you doing research on this too?
Not directly on this. I'll mention it in one of my talks tomorrow at the
Okay.
visitor center. But this lightning is very similar to the lightning that we see on Earth. It probably happens through the same kind of what we would call moist convection, but it's thunderstorms basically,
Okay.
where you get a lot of moisture that's coming up, and you have an electric field, and you get lightning.
All right.
And so we see this pretty much only on the night side, of course, because we have to be on the night side of the planet to see the lightning.
Based on some Juno images with a little
Yeah.
liberal license there. Marty, go ahead with your questions and comments for Caleb.
We have a couple of
Keaveney
questions.
here.
We have a couple of questions and comments. And Dwight Stephen Bolnecki, if I pronounced that correctly,
Yo, hi.
he has made several comments, but like his last one, he says, there's a magic when you look at the planet through a telescope. Suddenly, a bright dot in the sky becomes an incredible world. It is always breathtaking. thought that
Oh,
was nice.
that is a nice comment.
And then he has a question.
Thank you.
Where'd it go? Oh, do you know what the proportion of gas versus solid ground Jupiter is?
Say that again. The
Proportion of gas versus solid ground.
Oh, okay. Proportion of gas versus solid Jupiter.
Let's look at this thing on Uranus. That'll help you explain
Sure,
this. I've got
yeah.
this cutaway here
Mhm.
that's kind of similar to the gas planets. And you also like studying Uranus, okay? And I've been in astronomy a long time, and we know a lot of fun's made about Uranus, okay? So the International Astronomical Union is proposing a name change for Uranus. Did you know that?
I did not know that.
It's going to might be called Urectum.
Oh, yeah, that'll be
For more
helpful.
politically correct. Yeah. But, okay. Don't turn
You
it
were
off.
going to go
okay?
to that picture, right?
Yes, we're going to go to this picture right here and show you Uranus that is a lot like the other planets of how a cutaway of it there.
Right. Yeah. So the giant planets are generally speaking, they have at their outermost shell a weather layer that's a few thousand kilometers deep. So the depth depends on the planet. So for Uranus and Neptune, it's about 1,000 kilometers. Jupiter, it's about 3,000. Saturn's about 9,000. Compared to their radii, which are tens of thousands of kilometers. So their atmospheres, what we would call their atmospheres, are relatively shallow, actually. But that doesn't mean that there's a solid surface at the bottom of it. It more transitions into this higher density fluid. So in terms of their bulk density, they're closer to liquids. So the name gas giant is kind of a misnomer. Saturn is...
The closer you come to the center, things heat up by the pressure and so forth.
Yep.
That's why it becomes liquid of some sort of thing.
Yeah, something like that.
Okay. More like a jello in a way too, right?
Right. And then eventually you get deep enough that the pressures are so high that the hydrogen becomes conducting of electricity. And then that's when you get, that's kind of where the weather layer would terminate, where the atmospheric flows would stop. But then the further down you get, the higher pressure and then higher temperatures, and it's all kind of this really high temperature pressure fluid. And then at the core, there's some kind of rocky material that presumably was dust that coagulated in the initial formation of the solar system.
Okay. Well, Jupiter is, Uranus here has a ring around it. This is from the Keck Observatory on Earth of the atmosphere weather going on, only seen first by the Voyager spacecraft in the 70s. Also, Uranus is on its side like a bowling ball. It goes around. Something knocked it over. And they talk about the density and the conditions right for diamonds to be formed in a layer of Uranus. Is
Yes.
that correct? Any research on that?
I have not done any work on that. It
Your
is
girlfriend asked you to do research on that for a diamond ring? Or?
it's a theory that's been proposed because there is a relatively high composition of methane, which has one carbon atom and 4 hydrogen atoms.
That's right. It looks bluish, right?
Yep. So that methane absorbs a lot of red light. So then that's why the planet looks blue. There's no red coming out of it. So then if you, in theory, had high enough pressure and were able to split the methane into its carbon and its hydrogen components and then reassemble the carbons, you could get something like diamonds potentially. It's a very heuristic theory at this point. We don't really have a way of observing that right now, but there are people who are doing theoretical and modeling studies on it. That's not really my area of expertise.
There's
but
a whole other,
yeah.
every planet and every piece of the planet, including these rings taken by the Webb telescope in a fabulous infrared image. These were discovered when Jupiter passed in front of a star, and they saw the star blinking, and as it passed through, and then was obscured, and then blinked again, and they knew they had rings around there back in the 70s in there. But it's so much to learn. These planets are so gorgeous.
Yeah. If you go back to the
Sure.
previous one, I have a fun fact about it.
Yeah.
You can see those dots around the rings. Those are the moons. And this is of Uranus, right? Or is
Yes.
This, yeah. So those moons are named after Shakespeare characters,
Yes.
which is one of
Oh,
my.
really?
Absolutely. Puck,
Miranda.
Miranda's like a jumbled up mess. All the moons of the planets kept a theme. Like Pluto's moons are named after the underworld characters, Hades and stuff like that. But yeah, Puck,
Oberon,
yeah,
Miranda.
yeah.
Uh,
That was
Yeah.
by the influenced by the discovered by the great astronomer William Herschel in England. So yes, Marty. Question.
Question from Dean Babcock. Will the budget cuts affect the Juno program?
Great question. That's how we were going to end here. I was going to say, what does the future hold? What does we got a lot of news out there of stuff being cut left and right for science. Certainly couldn't agree with any of that. But what's the feeling on the ground roots of our university, Yale? There.
Yeah, well, I'm lucky being at Yale. We have a lot of resources to begin with. It's tricky. It's really hard to say. But all of this work that we've been talking about is the results of publicly funded science for the most part. All these NASA programs are ultimately rooted in the original creation of NASA. And so it's the fact that the Apollo programs were successful that then all these other, like the Voyager satellites and Juno, were eventually publicly funded. We have this spirit of funding these really interesting space science projects in the United States. That is going to become trickier over the next few years, depending on what cuts happen to the budget.
Well, this is
Stay optimistic.
It's
Yeah,
hard.
stay
Stay curious,
optimistic.
stay optimistic.
Stay curious, stay optimistic. It might instill more public funding of these things where people that want to support their universities want to do things. But when you talk to a young man like this and young women that we talk to, the young engineers at Via Space that we've had on here, I mean, you're going like, why do you want to stymie these brilliant minds, young minds that want to do this now? And we'll be out there fighting for that. Marty?
Yeah, question from Michael Bruno. Is Juno weathering the radiation well? Will it last quite a while longer?
Is Jupiter weathering
Juno.
the
Juno?
spacecraft
Oh,
Juno.
Juno. Okay.
There's a hellacious radiation
Right.
around Jupiter.
Yeah. So Juno has deteriorated some. It originally was slated for a 5-year, I believe it was 5-year initial funding period, and then the instruments were holding up well, and so then it's continued to receive funding. All these images come from JunoCam, which is an instrument on it's a public outreach camera, but that has also produced a lot of science, and that has deteriorated some. There was a period of a few orbits where it was not working, but it is now working again, as far as I know. I would say we probably have another, depending on the instrument, 2 or 3 years that we can be really optimistic about getting more data. At this point, anything we keep getting is a win, because it's been around Jupiter for so long.
And there's a lot of citizen scientists that are also analyzing this data to help you. How isn't it? an angle a lot of people
Yes.
don't know about,
Yeah, so all of these images were processed by citizen scientists for the most part.
which means volunteers.
Right. So they're not paid. A lot of them are not planetary scientists by training. One of the people who is the best in the world at this is a microbiologist,
What's his
Oh.
name?
John Rogers.
Yeah, you're telling me about that. And you
Yeah.
can play with these images all you want because they're owned by the government,
Yes.
you and the taxpayer.
Yep.
So that's what he's talking about. You go to the Juno website, you can harvest these, do things that you want with them, and make a mural of them and put them on your wall, whatever there.
Yep.
Marty, another question while we're wrapping up here with Caleb Keaveney and Caroline Shumacher of the Astronaut Scholarship Foundation.
Yeah. Michael, I'm sorry, Dwight Stephen Benecke, is the monolith still floating out there, and is it still full of stars?
Is the monolith still floating out
From
there?
2010,
Oh.
A Space Odyssey.
I unfortunately have not seen that movie.
Okay. Well,
Oh, he's a baby.
I
He's a
know.
baby.
I was born in
Great one.
2001.
Great
so-
one.
Oh, don't say that.
That's 2001 in there. Good one there. Well, that's a good point to end a beautiful conversation here with a young mind that we will follow up, Caroline, about what this young man's doing on there. Anything that you want to interject that we hadn't talked about?
No, I just think, the work of our scholars is pretty incredible. And I think it's important that, we share it. I think I believe people don't even have a grasp of what students are capable of doing in undergrad. You kind of go back. I know my days, it was very different. I was not doing anything profound like Caleb or any of our other scholars. So it's impressive. And I encourage, if anyone's coming out to the visitor complex tomorrow, stop out and see him. He'll be at Journey to Mars.
Only being Journey to Mars there.
Yeah,
across
at
from the
11 a.m. and
I think it's 11:30 and 2:30.
11:30,
Yeah, we
2:30.
might
So
be able to do that.
if you want to come
11:30
out,
and
his
2:30.
presentations will be great. Two different
Okay.
ones, right? So it's part of their Earth Day celebration. So he'll be kind of tying everything back to
Earth
our
Day
own
celebration
thing.
tomorrow, huh? We'll have to
Yep.
get our arms wrapped around that. Caleb, just it's fun to be part of this because you meet some celebrities, huh? Who's
Yeah.
impressed you or sticks out in your mind or says, or Mom, you can't believe who
Well,
this-
the one that Christina Koch went to my high school.
Christina
Um,
Koch, okay.
So she was the number one person I wanted to
Artemis
meet
2 astronaut.
for years and years. I always wanted to meet her, and then when I got the scholarship and flew down here, I got to meet her at my Innovators Week conference.
Uh-huh.
And that was like I couldn't believe it. And then when I graduated, she sent me a video that was basically like congratulations on graduating, and that was a huge moment for me that I'll remember that forever.
So Christina's an astronaut scholar.
Yeah.
Yeah.
Oh, she
Yeah.
is an astronaut
Mhm.
scholar too.
Yeah.
I had her on my bet to be the first woman on the moon. She'll be
be the first
orbiting.
to go, yeah.
She could still go back and so forth. Spent 300 days on the space station with Jessica Meir.
Mhm.
Did a spacewalk together, stuff like that. So you met some of the old guys
Yeah,
and
well,
girls. I mean, too.
yeah,
Well, you meet a bunch of them here in a month.
But, yeah.
met a bunch of them. Harrison Schmidt was the Apollo astronaut who I got to meet. Kurt Brown, of course, who is the chairman of the board.
Handed you your certificate.
Yep.
Yeah, Kurt Brown, a 6-time astronaut, 4 commander.
Yep.
No, 3 a commander and 3 a pilot, I think, out of him in there. Yeah.
Yeah, we were just talking about Nicole Stott.
Yeah.
Got to meet her.
Oh, good.
So-
Yeah, she's a wonderful earthling for sure, man.
Yeah.
Nicole's a big sponsor of us there. Was there anything we didn't ask you that you'd love to share on behalf of your twin brother, Aiden, and your family members out there?
Well, no, I just wanted to say thanks to Caroline for having me come down here. This is like, I just passed my qualifying exam last week.
Yeah.
So this is like my victory lap. That I get to, come down here and talk about science and see I just love being here. I mean, all the roads being named after astronauts or space missions, and like I get to, see out my hotel room window. I see it's the visitor complex. It's just, this is like one of my favorite places in the world. So I'm just
Yeah.
happy to be here.
Well, we're glad of that. We're
But-
glad that you found the American Space Museum,
Yeah.
and we'll look around a little bit and see some of our artifacts here. And thank you, Caroline.
Oh, it's
All
a
right,
pleasure.
and we broke the ice. I want to see more of these great minds that
Yep.
you're helping perpetuate for our great country here and our great science. So thank you, everybody, for watching. We've kicked off another week of Stay Curious. We're into our 5th year, Marty and I, over 1,260 episodes. And
Wow.
along for the journey, of course, Tommy Usiak, who was just in here and a couple hours ago. Tom, he's watching. Julie Clay. You'll hear more about Julie helping us at the Shuttle Fest. Connie McDaniel, our #1 volunteer at the Shuttle Fest this year. She's been at all 4 of them and been our right-hand person there.
Wow.
She's a North Carolinian, she's got to
All right.
point out, proudly from Charlotte. Mark Thel, you and your wife were a pleasure to meet at Shuttle Fest. Bob Mayran, Dean Babcock, Mitch Rothman of Man Space Facebook. Thank you, Mitch and Paula. They were at Shuttle Fest, as in the one and only Carlton Bailey. CB's got a lot of pictures I'll start putting up there. Gary Gerald, we missed you, and I owe you a phone call, I realize. So give me a call, Gary, if I don't get back to you. He's going to be harvesting Vidalia onions up there in Collins, Georgia, and I'll bring you some. when
Oh,
he
I
brings
do
them
love
to me.
some Vidalia.
Yes. Dave Stangy and Mia. Hi, little Mia. She's 2 years old, and she loves this. His granddaughter. So get Grandpa to get you a telescope so you can see Jupiter. Michael Bruno, thank you for your great questions. My daughter Jessie is watching probably.
Oh.
Cliff Watson in Pomona, Australia. And Elena Adkaher, she is in South Africa somewhere.
Wow.
Dwight Stephen Bonecki. Dwight, great to see you in Germany. Save up for Shuttle Fest for 5. It will certainly be something to see again. Rocket Lady Elizabeth, thank you. It's great to see you at Shuttle Fest. Tom Celentano and DC Fun watching today this broadcast of Stay Curious. So again, thank you to my guests, Caleb and Caroline, who's the big shot there to Scholarship Foundation, and our
Big
friend.
shot might be a
But she's
stretch.
no, you're not a big shot at all. You're like me.
5'2".
We have a mission to go on, and we're full steam ahead for both of our organizations. So tomorrow we'll do a little bit of Earth Day, give some love to everybody at Shuttle Fest, rack up some pictures and talk about it, and get our week kicked off here. So until then, thank you, Marty Winkle, for a great job on our Streamlabs production. And I am Mark Marquette saying we can't wait to see you tomorrow to bridge the space between us. Thank you so much.